Hi guys, how are you? Welcome back to the third part of current electricity chapter. So in previous videos, I did solve the numericals up to 50 of previous year Neet questions. Now we are going to solve from 51. So let's continue. Question number 51, they're asking the total power dissipated in watt in the circuit. Okay, super. So just observe the circuit here itself. Question number 51, right? Okay. So these two resistors are looks like they are connected in parallel, right? When two resistors 3 and 6 ohm are connected in parallel, then what's going to be equivalent resistance? Equivalent resistance is going to be 2. Equivalent resistance of these two is going to be 2. How? So 6 into 3 by 6 plus 3. So use this method, it's going to be 18 by 9, which is equal to 2 ohms. So this is the equivalent resistance of 6 and 3 connected in parallel. Remember, we are going to use this so many times. So this 2 ohm resistor is connected in series with 4 ohm. So these two are in parallel. Equivalent is 2 ohm. 2 ohm and 4 ohm are in series. Then remaining circuit looks like this one. 2 ohm, 4 ohm and 2 ohm. 4 ohm and 2 ohm are looks like they are connected in series. Resultant resistance is 6 ohm. Then question they are asking is power dissipated, that is V square by R equivalent. V value is 18 into 18 divided by R equivalent. R equivalent is 6 here. 6 3s are, so answer is 54 watts. Which option? Option B is the correct answer. Got it? Next, question number 52. Power dissipated in across the 8 ohm resistor in the circuit is given by 2 watt. Okay. Power dissipated in watt units across the 3 ohm resistor. Okay, super. So let's use this circuit itself. They gave power dissipated in 8 ohm resistor. How much they have given? It is equal to 2 watt. So 52. Let's find out voltage across 8 ohm resistor. So power is equal to V square by R. Then V square is equal to power into resistor. Power value is 2. Resistance value is 8. And V square is equal to 16. Then V is equal to 4 volts. This 4 volts voltage is same across this parallel combination. This is 4 volts. We know voltage division. When two resistors are connected in series, voltage gets divided. Let's calculate voltage across 3 ohm resistor. Voltage across 3 ohm resistor is equal to total voltage across 3 and 1 ohm, that is 4 volt, into voltage across the same resistor, that is 3, divided by sum of the resistors, that is 3 plus 1, which is going to be 4. This is voltage division method. This 3 plus 1 will get cancelled out, 4 and will get cancelled out. Resultant is going to be 3 volts. I need power dissipated by 3 ohm resistor, right? So power dissipated by 3 ohm resistor is V square divided by R. V square is 3 square divided by 3, which is equal to 3 watt. Good. Which option? Option A is the correct answer. Understood? Okay, so let's move on to the next. Next question number 53. When a wire of uniform cross section A and length L, resistance capital R is bent in the form of a circle, resistance between any two of diametrically opposite points will be. Okay, so this is how straight wire is bent. Now this part of the wire is of half of the length, this part of the wire is of half of the length, then resistance also get reduces, that is R by 2 and R by 2. Between these 2 points I need resistance, that is R A B, which is equal to R by 2 and R by 2 connected in parallel. Resultant resistance is going to be R by 2 by 2, which is equal to R by 4. This is equivalent resistance. Okay, check out that. So why I wrote R by 2 R by 2? Because L length wire is converted in the form of a circle. Each length is L by 2 and L by 2. So resistance also reduces by half, which is R by 2 and R by 2 connected in parallel. Resultant resistance is R by 4. Okay, so let's move on to the next. Which option? Option A is correct. Next, resistance N each of R ohm when connected in parallel give an equivalent resistance of R ohm. Okay, 54 solution. N resistors connected in parallel, then R equivalent is equal to R by N. Then if these resistors were connected in series, the combination would have a resistance in ohm. Okay, so this is parallel combination, right? If they are connected in series, then R equivalent is equal to N times of R. This R I need in terms of capital R, right? Just observe from the parallel combination, what's the value of small r? Small r is equal to capital R into N. So just substitute it here. So N into capital R into N. So then R equivalent is equal to N square times of capital R. So which option matches? Option A is the correct answer. Understood? Next question number 55. When three identical bulbs of 60 watt and 200 volts rating are connected in series to a 200 volts supply, the power drawn by them will be. Okay, so how many bulbs are there? Three identical bulbs. Try to replace them in the form of a circuit like this. With the help of rating they have given, I told you earlier, so we have to find out resistance of all the three bulbs, right? So what is the total supply voltage? 200 voltage. 200 volts. Each bulb rating is 60 watt 200 volt. 60 watt 200 volt. 60 watt 200 volt. Okay. So let's find out resistance of each bulb. R is equal to V square by P. V value is 200 into 200 divided by P. P value is power, that is equal to 60. So 1 0 will get cancelled. You are going to get 400 divided by 6. This is the resistance of each bulb. So all these bulbs are connected in series, right? Let's find out equivalent resistance. R equivalent is equal to, as there are 3 resistors, it's going to be 3 times of 1 R, that is 400 divided by 6, which is equal to 200 ohms. So each resistor is of resistance, each bulb is of resistance 200 ohm. So the total supply voltage that is given is 200 volts. Then power dissipated formula V square by R. V square is 200 into 200 divided by R. So a small mistake here. Just check out here. Equivalent resistance 200 into 20 is 4000. It's not 400. So now this is going to be 2000 ohms. So V square by 2000 ohms. These 2 zeros will get cancelled. One more 0 and 2 will get cancelled. Answer is going to be 20 watt. That's the answer. Which option matches? Option D is the correct answer. Okay. Next question number 56. Two 200 volt 100 watt bulbs are connected first in series and then in parallel. each time the combination is connected to 200 volt AC supply, the power drawn by the combination in each case respectively. Okay. I have a direct formula to answer this question. When two bulbs are connected in series or in parallel, to find out what is the total power consumed by those two bulbs. If it is a series combination, it is applicable for two bulbs only. If the combination is a series, then equivalent power is equal to P1 P2 by P1 plus P2. It's like a resistors connected in parallel. And if it is a parallel combination, then equivalent power is equal to P1 plus P2. Let's substitute. So it's going to be 100 into 100 divided by 100 plus 100, 200. Answer is going to be 50 watt. Then P equivalent in parallel combination, P1 plus P2, 100 plus 100, 200 watt. Which option? Option D is the correct answer. This is direct formula. It is applicable for the bulbs connected in series and parallel. If it is series, it's like a resistors connected in parallel. If it is parallel, it's like a resistors connected in series. That's the combination that we have to use here. Okay, let's continue. Next question. An electric kettle has two heating coils. When one of the coil is connected to AC source, the water in the kettle boils in 10 minutes. Okay. So let's just understand this question. Question number 57. So electric kettle has two coils. One of the coil is connected to AC source. Water in kettle boils in 10 minutes. Okay, let's the power supply is V. So heat energy formula is power into time, right? So I'm talking about coil 1. Coil 1. So formula is V square, V1 square by R1 into time T1. T1 is 10 minutes. That's what they have given. Okay. Next. In coil 2, when the other coil is used, water boils in 40 minutes. Coil 2. Same formula. H is equal to P2 into T2, which is V2 square divided by R2 into 40 minutes. Okay. Super. As heat generated is the same. We know that because same quantity of water is being used to boil. So amount of heat generated here, it is the same. So you can equate these two heat values. That is V1 square divided by R1 into 10 is equal to V2 square by R2 into 40. So V1 square, V2 square will get cancelled as supply voltage is the same. That is V1 is equal to V2, which is V. And then R2 by R1. Otherwise, R2 is equal to 4 times of R1. Okay. So they said they are connected, right? So when they are connected in parallel here. The time taken by the same quantity. Okay, super. So what's going to be the formula for parallel combination of resistance? R equivalent is equal to R1 R2 by R1 plus R2, right? Okay. So in this case I need power. So heat again, it is going to be V square by R equivalent, that is R1 R2 by R1 plus R2 into T. So as heat is the same, you can equate with any one of these cases. Okay. So let's try to equate with any one of these. So let's use equation 2. This is equation 1. Let's use equation 2 and you can write down this as heat as V2 square or simply V square divided by R2 into 40, which is equal to V square R1 R2 by R1 R2 into T, right? So this R2 will get cancelled, and V2, sorry, V square, no? This V square and V square will get cancelled. So we know that R2 is equal to how many times of R1? It's 4 times of R1, right? If you substitute in place of R2 4 times of R1, it's going to be 5 times of R1. R1 will get cancelled. Then finally it is going to be 5t is equal to 40. Then t is equal to 8 minutes. That's the answer. Hope you understand. So option A is the correct answer. Okay, let's move on to the next 58 solution. The circuit is given like this, and just observe. So let's answer here itself. They're asking current in the circuits. So first of all, just observe these two resistors looks like they are connected in series, right? So the resultant resistance is going to be, so resultant resistance of these two resistors is 12. So you're going to get 12 ohms. This is in parallel with this 3 ohm resistors. So this combination is parallel. So 12 and 3 ohm are connected in parallel. Then R equivalent is equal to 12 into 3 by 12 plus 3. That is 15, which is equal to 3 ones are 3 fives are, and it's going to be 2.4 ohms. Question they're asking current I is equal to V by R. V value 4.8 volt divided by 2.4 ohm, which is equal to 2 ampere. So which option? Option D is the correct answer. Got it? Very good. Next, question number 59. 3 equal resistors connected in series across a source of EMF together dissipates of 10 watt of power. Okay, so there's a 3 equal resistors, right? So let me imagine each resistor is of resistance R ohms. As they are connected in series, so it's going to be replaced as 3R as equivalent resistance, and supply voltage is, let's say, E. So power dissipated formula is E square by R. Power is 10 watt, which is equal to E square by R equivalent is 3R. This is the formula for power dissipated. Okay, so let's try for the another case. What will be the power dissipated in watt if the same resistors are connected in parallel across the same source? So if resistors are connected in parallel, then their equivalent resistance is going to be R by 3. As they are equal resistors, it's going to be R by 3. So same EMF. So power is equal to E square by R equivalent, right? So which is replaced as E square divided by R equivalent is R by 3, right? Then what's going to be E square by R from this? E square by R is equal to 30. So let me replace this. E square by R is equal to 30. Then power is equal to 90. So this value is replaced as 30. 30 into 30, 90 watt. Which option? Option D is the correct answer. Got it? Okay, so let's move on to the other. Just now we solved this model. They're asking current flowing through the circuit. These two resistors looks like they're connected in series. So resultant, they're connected in parallel with 3 ohms. So this is parallel combination. So series equivalent resistance is going to be 6 ohm. 6 ohm and 3 ohm are connected in parallel. Then resultant resistance is going to be, we already spoke about this. 6 and 3 connected in parallel is equivalent to 2 ohms, right? Now current in the circuit is V by R. V value is 2 volt and R value is 2. So answer is going to be 1 ampere. Which option? Option B is the correct answer for question number 60. Got it? Okay, next. If two bulbs whose resistances are in the ratio 1:2 are connected in series, the power dissipated in them has the ratio of 61. Resistances they have given it is in the form of a ratio. General formula for power is they're connected in series, right? So you can take it as I square R because current flowing through the resistors is the same, right? So P1 by P2 is equal to R1 by R2, right? So can we use this relation? So as R1 by R2 is equal to 1 by 2 ratio, then P1 by P2 is also of 1 by 2 ratio. So which option matches? Option D is the correct answer for this question because it is directly proportional to answer it. As it is connected in series combination, I am taking it is as I square R formula so that I can make it as equal because in series current is going to be same, right? Next question number 62 solution. What will be the equivalent resistance between the points A and D? Okay, so let's answer here itself. They're asking resistance between A and D. So whenever I am considering A and D, so B is going to be open circuit. That means current flowing through it is 0. And current flowing through it is also 0. Then no need to consider those two resistors. Got it? So whenever current flowing through them is 0, no need to consider those resistors. Just observe how I am going to replace it. As I said earlier, we can eliminate resistor B and C here because current flowing through them is 0. And because they are asking resistance between A and D terminals only, right? So no need to consider these two resistors. So observe this, if these two resistors are removed completely, remaining circuit resistors, observe them. So let's replace those resistors. Now these two resistors looks like as if they are in series combination, right? If there looks like as if their series combination, their resistance is 20. The resistance of these two resistors is again, this is series combination, this is also series, which will give you 20 ohm and this is also 20 ohm. Now these two combinations, these two are connected in parallel. So 20 and 20 are connected in parallel. So resultant circuit looks like this. So there is 10 ohm and 10 ohm and 10 ohm. So resistance between A and B. So RAB is equal to 30 ohm. This is the correct answer. Got it? So which option matches? Option A is the correct answer. Just check out once again. So as they are asking resistance between A and D, B and C elements can be removed. Okay. Now this is one series combination. Equivalent resistance is 10 ohm. The 10 ohm resistance is connected in series with the remaining resistors. So answer is going to be 30 ohm. Let's move on to the next question. In question number 63, two wires of the same metal have same length but their cross sections are in the ratio 3:1. They are joined in series. The resistance of the thicker wire is 10 ohm. The total resistance of the combination will be okay. Length is same but of different area of cross section. We know the formula for resistance R is equal to rho L by A. And both are of same metal, that's why rho is also constant. Then R is directly proportional to 1 by A. So R2 by R1 is equal to area of cross section A1 divided by A2. A1 is 3 by 1, A1 by A2 ratio. I need resistance R2. So the thicker wire, that is first wire R1, is going to be 10 ohms. That is 3 by 1 into 10 ohm, which is equal to 30 ohm. This is the resistance of the thinner wire. Now the question they are asking, total resistance of the combination is total. They said they are connected in series combination, right? If they are connected in series, then what's going to be R equivalent? R equivalent is R1 plus R2, which is equal to 40 ohm. R1 is 10 ohm, R2 is 30 ohm, which is equal to 40 ohm. Which option? Option A is the correct answer. So let's solve question number 64. A heating coil is labeled as 100 watt and 220 volts. The coil is cut in half and the two pieces are joined in parallel to the same source. Okay. So initially the heating coil is arranged like this. Let's say, let's replace it with the help of a bulb. 64 cell. So source is, let's say, E. I'm just replacing it with the help of a bulb so that it is very easy for me to analyze. 100 watt and 220 volt. So let's find out resistance. R is equal to V square by P, right? V value is 220 into 220 divided by 100. This will get cancelled. 22 into 22 is 484 ohms. Now, so they are cutting this into two parts. That means resistance also going to be divided into two parts. That is 242 and 242. And after cutting, they are connected in parallel. That means this is the combination is going to be. This combination is connected to the same supply voltage, which is E. This is going to be 242 and this is 242. In this case, equivalent resistance. This equivalent resistance is first case. Right now, equivalent resistance is going to be 121 ohms as they are connected in parallel. So we know that energy is, so whatever the supply they are giving, it is the same. They are asking power. Power is E square by R, right? As E is the same, power is inversely proportional, right? So it's going to be P2 by P1 is equal to R1 by R2, whereas R1 is 484 ohms divided by, next R2 is 121, which is equal to 4. Then they're asking P2, right? So P2 is equal to 4 times of P1, where P1 is 100 watt. So it's going to be 4 into 100. Answer is 400 watt. This is the answer. Which option? Option B is the correct answer. Next question we'll answer here itself. Observe this. 6 resistors of 3 ohm each are connected in along the sides of a hexagon, and 3 resistors of 6 ohm each are connected along AC, AD, AE as shown in the figure. The equivalent resistance between A and B they are asking. Okay, so I need equivalent resistance between these 2 points. Let's bring these 2 points outward. A and B. So now observe, these 2 resistors looks like they are connected in series. This combination is in parallel with 6 ohm. So this resultant is a 6 and 6 connected in parallel. We are going to get 3 again. So this complete combination looks like as if that is connected in, observe carefully, these 2 resistors connected in series. Resultant is going to be 6 ohm. This 6 ohm and this 6 ohm connected in parallel. Resultant is going to be 3. This is going to be 3. So similarly, 3 ohm and this 3 ohm connected in series. Resultant 6. 6 and 6 are connected in parallel. Resultant 3 again. So till now we got 3 ohms as an equivalent resistance, this complete combination. Again this 3 ohm and 3 ohm are connected in series. Resultant is connected in parallel with 6 ohm. Again answer is going to be 3. 3 and 3 are connected in series, resultant is 6. 6 and 3 are connected in parallel, then R equivalent is equal to 6 and 3 connected in parallel, 6 into 3 by 6 plus 3, which is equal to 2. Which option? Option A is the correct answer. I'll just go through this again and again, you will understand this. Got it? Next question number 66. Three resistors, each of resistance 4 ohm, are connected to form a triangle. Okay, so all of them are of same resistance. They are connected in like this, the form of a triangle. The resistance between any two terminals. Okay, let's find out resistance between these two. They're asking between any two terminals. Now these two terminals looks like as if these two resistors looks like as if they are connected in series combination. Resultant resistance is going to be 8 ohm, right? So this 8 ohm and this 4 ohm, they are connected in parallel. So this 8 to 4, then R equivalent is equal to 4 into 8 by 12. So 4 3s are, answer is going to be 8 by 3. Which option? Option D is the correct answer. Got it? Next question number 67. Question they are asking is current through 3 ohm resistor is 0.8 ampere, then potential drop through 4 ohm resistor. Okay, let's answer this question here itself. Observe carefully. So 3 ohm resistor, current flowing through it is 0.8 amperes, right? Observe this. If 0.8 amperes flows through 3 ohm resistor, some voltage will drop across this, plus minus. Voltage is going to be I into R, that is 3 into 0.8. 2.4 volts will drop across resistor 3 ohm. Is this 2.4 same as 6 ohm resistance also? Yes, it is, because they are connected in parallel. Then what's going to be current? Current is going to be 2.4 divided by 6, which will give you 0.4 ampere. 0.4 ampere. So if you observe here, 0.8 amperes and 0.4 amperes both are entering here, which will give you 1.2 ampere. Question they are asking is voltage across 4 ohm resistor, plus minus V is equal to I into R. V is equal to I value is 1.2 here, into R is 4. Answer is 4.8 volts is the correct answer. Which option? Option D is the correct answer. Got it? Let's solve the next question, 68. In the network shown in the figure, each resistance is 1 ohm. The effective resistance between A and B. This is a different type of network. Just observe here. If you draw a line here. So due to symmetry, left side part of the circuit and right side of part of the circuit, both are similar, right? If you come across this kind of network, you just can replace the joint here. Just observe. So whatever the joint we have, we just can lift it up like this. This joint point you just can remove, as it is a symmetry. So this kind of method is applicable only for symmetry. This is 1 ohm, 1 ohm, 1, 1, 1, 1 on. So these two are, first these two are connected in series. Resultant is 2. 2 and 1 ohm connected in parallel. Resultant is 2 by 3. So this is going to be 2 by 3. This 2 by 3, 1, 1. These are connected in series. Resultant is 2 by 3 plus 2 it's going to be 8 by 3. So now 8, this remaining circuit can be replaced like this. So this is 8 by 3 and this is 2, A, B. Now 8 by 3 and 2 are connected in parallel, then R equivalent is equal to 8 by 3 into 2 divided by 8 by 3 plus 2, which will give you answer. It is a 16 by 3 divided by 6 plus 8, 14 divided by 3. So this will get cancelled. 16 by 14. So you can replace it as 8 by 7. Which option? Option D is the correct answer. Just observe question number 69. So you are given a several identical resistances, each of value 10 ohm and each of capable carrying 1 ampere of current. It is required to make a suitable combination of these resistors of 5 ohms which can carry a current of 4 amperes. So I have to design a circuit. Each resistance is of 10 ohms and I have to get resultant as 5 ohm and 4 amperes of current. Let's begin. It comes with only by thinking. Okay, it's not that much easy to answer it directly. So I'm just selecting a resistors like this. Why I'm selecting 4 different paths? Because in parallel combination only I can add the current, right? So current flowing through each resistor is 1 ampere. 1 ampere, 1 ampere, 1 ampere. This is of 10 ohm, 10 ohm, 10 ohm, 10 ohm, 10 ohm, 10 ohm. So these two are connected in series, resultant 20 ohm. So as current is 1 ampere, 1 ampere, 1 ampere, 1 ampere, total current is going to be 4 amperes which enters. So this kind of 20 ohm resistors connected a 4 combinations. So R equivalent is going to be 20 by 4, which is equal to 5 ohm. Yes, I am getting 5 ohm as an equivalent resistance and 4 ampere. So total number of resistors required is 8 resistors. Next, question number 70. It comes only by thinking. It's not that much easy to answer immediately. 4 electric bulbs are connected in series across 220 volt supply. After one bulb is fused, the remaining 49. One bulb is fused, the remaining 39 are connected again in series across the same supply. The illumination will be. So as supply voltage is same, we know the power formula. Power is equal to E square by R or V square by R equivalent, right? So it is the same. Then power is inversely proportional to R equivalent. In which case R equivalent is more. See, if R equivalent is more, then power is going to be less. Let's decide this. So R equivalent of 40 bulbs more than R equivalent of 39 bulbs. Correct? Because 49 bulbs in the sense, simply let me write down it is as 40R. This is going to be 39R. So we can replace it. So that's why total power dissipated by, as resistance is less, power dissipation is more, right? So power dissipated by 39 bulbs is greater than power dissipated by 40 because it is equivalent resistance is inversely proportional. So option B is the correct answer. Okay, let's try question number 71. N equal resistors are first connected in series and then connected in parallel. What is the ratio of maximum to minimum resistance? Okay, so if they are connected in series, then equivalent resistance R1 is equal to N times of R. If they are connected in parallel, then equivalent resistance is going to be R by N. So they're asking maximum to minimum. So this is the maximum possibility and this is minimum. Ratio of maximum to minimum is nothing but R1 by R2, series by parallel. In series resistance increases and in parallel resistance decreases. It's going to be NR by R by N. R will get cancelled. You are going to get N square. Which option? Option C is the correct answer for question number 71. Got it? Next topic is based on EMF, cells and internal resistance. Before going into that, I would like to give a small note about a cell. Just observe this. So cell is a combination of EMF and internal resistance. This complete combination is called as a cell. And they are connected to a load resistor capital R. So voltage across a cell is nothing but terminal voltage. This is the terminal voltage. Here I can say voltage across resistor R is the same as voltage across a cell, which is called as terminal voltage. Because load resistor and the complete cell, they are connected in parallel combination, right? So that's the reason voltage across the load resistor, voltage across the cell, both are same as terminal voltage only. That's the meaning over there. And one more thing, so you have to understand is combination of cells, series combination and parallel combination. So first of all, I would like to give a note before getting to series and parallel combination. In series itself, we have two different types, that is series aiding and the series opposing. If the cells are connected like this, that is plus minus such kind of combination, E1 and E2, then E net is equal to E1 plus E2. So this is called as series aiding. So we have to cross check whether it is series aiding or opposing. So observe this, whether it is plus minus or minus plus, this kind of combination is called as a series aiding. Next one is a series opposing. It's like this, plus minus plus, or plus minus plus, or plus minus plus minus. This kind of combination is called as series opposing. Let's say this is E1 and this is E2. In this case, we have three different cases. One is E1 greater than E2. Then, so E net is equal to E1 minus E2, and we have to follow the E1 sign. This is E net representation. So second case is if E1 is less than E2, again E net is equal to E2 minus E1. We have to follow the E2 symbol. This is E2 minus plus. Now the third case is E1 is equal to E2, then E net is equal to 0. If E net is equal to 0, you can replace it with a short circuit. That's the way we can replace the circuit. Got it? So this is the basic thing to understand. Then we'll move on to the actual numericals. Okay. Let's start with question number 72. A set of n equal resistors of resistance capital R are connected in series to a battery of EMF E and internal resistance capital R. Okay. So just observe the diagram or circuit. So EMF E, internal resistance capital R, this is connected to n number of resistors which are connected in series, that is equal to n times of capital R, and current flowing through the circuit is I. How to find out current in the circuit? I is equal to E by R equivalent, right? So these two resistors looks like as if they are connected in series combination. Then resultant resistance is going to be R plus NR. That means R into n plus 1. This is the value of current. Okay, the same resistors, n resistors, they are connected in parallel. Okay, so if the n resistors are connected in parallel, equivalent resistance is going to be R by n. This combination is again connected across the same cell. It is E and Kepler. Now current flowing through the circuit is 10I. Now 10I is equal to E divided by R equivalent. R equivalent is R plus R by n. Again R common, it's going to be 1 plus 1 by n. So let me replace E by R into, in place of I, we can replace it as E by R into n plus 1, right? So let's replace and try this. In place of this I am going to substitute this 10 into E by R into n plus 1, which is equal to E divided by R into n plus 1 divided by n. So R into n plus 1, R into n plus 1, E will get cancelled. Then n goes to numerator, then n is equal to 10. Which option? Option A is the correct answer for this question. Okay, let's move on to the next question. Question number 73. Question they are given is, the internal resistance of a 2.1 volt cell which gives a current of 0.2 ampere through a resistance of 10 ohms is. Okay. With the help of given data, try to write down a circuit. So, EMF of a cell is 2.1 volt. Internal resistance we don't know, that's what we have to find out. Load resistance is given, which is equal to 10 ohm. Because of this cell, 0.2 amperes of current is flowing through the circuit. Then what about internal resistance? That's what they're asking. Okay, so let's try. So this is plus and minus. Wherever current is entering, that is going to be positive, and remaining it is going to be negative. 0.2 into 10, it is going to be 2 volt. And 0.2 amperes is entering resistor smaller, that is internal resistance. Now just observe plus minus. These two cell looks like as if they are connected in series, aiding or opposing, plus minus and minus plus. These two cells like they are connected in opposing in nature, series opposing in nature. So do I have to subtract or add? Subtract. Whose direction we have to follow? High potential. So as we have plus 2 volts here, how much voltage will drop across the resistor, internal resistance? So the total voltage is going to be 2.1 volts, 0.1 volt. So if I write 0.1 volt here, these two are connected in series opposing. 2.1 volt minus 0.1 volt will give you 2 volts, which is appearing across load resistor. That's the correct way. Then I is equal to V by R. Use that formula. Then R is equal to V by I. Then R is equal to V value is 0.1. I value is 0.2, which is equal to 0.5 ohms. Option D is the correct answer. Understood? Next, question number 74. A cell having EMF E and internal resistance smaller connected across a variable resistor capital R. Okay. EMF, internal resistance connected across a variable resistor capital R. This is a variable resistor. That's what they have given in question itself. As the resistance R is increased, the plot of potential difference V across capital R is given by. So I have to find out voltage across capital R, right? So I know we know the voltage division method, right? These two resistors, smaller and capital R, looks like as if they are connected in series combination. Then voltage across resistor capital R can be replaced as E into capital R divided by smaller plus capital R. This is the method that we can use. which can be replaced as E divided by R by capital R plus 1. This is the equation for voltage across. Let's vary the value of R in these two cases. For example, if R is equal to 0, then R by capital R is going to be infinity. So anything by infinity is going to be 0. So VR is equal to 0. Next thing, if R is equal to infinity, small r by R is going to be 0, then you are going to get VR is equal to E itself. That means voltage is increasing from 0 to maximum value, that is E. So only option which is matching it is option C. That's the correct answer for question number 74. Understood? Let's try question number 75. A current of 2 ampere flows through a resistor, 2 ohm resistor when connected across a battery. Okay, so battery in the sense EMF and internal resistance. A 2 ohm battery is connected. If I connected 2 ohm battery, if I connected 2 ohm resistance across a battery, 2 amperes of current is flowing through it. The same battery supplies a current of 0.5 ampere when connected across 9 ohm resistor. Okay, same battery, I'm just connecting it to a 9 ohm resistance. Right now it is producing 0.5 amperes of current, same internal resistance because of same battery. Now question they're asking, the internal resistance of the battery is, okay, super. Let's use KVL in both the equations and try to solve those two equations. So entering it is positive, leaving minus. Entering positive, leaving minus. Voltage across this 2 ohm resistor is 4 volt. Voltage across this smaller resistor is 2 into R. So let's use KVL. That is, you can start from anywhere, that's your wish. Minus E plus 4 plus 2R is equal to 0. Then from this E is equal to 2R plus 4. This is equation 1. So you can start either in clockwise direction or anti-clockwise direction. So you can start with any starting terminal or ending terminal of the any element. I'm choosing here starting terminal. So let's say plus minus, again try to move in clockwise direction and try to answer with the help of KVL. So that is minus E plus, so it's entering is positive, leaving minus. 0.5 into 9 is going to be 4.5 volts. So entering is positive, leaving negative. So answer is E minus E plus 4.5 plus 0.5 into R is equal to 0. Then E is equal to 4.5 plus 0.5 R. So just as battery is the same, just can equate these two equations. So 4.5, instead of 4.5 you can write down it is as 9 by 2 plus 1 by 2 into R is equal to 2R plus 4. So 9 plus R is equal to 4R plus 8. So 3R is equal to 1 and R is equal to 1 by 3 ohm. Which option? Option B is the correct answer. Got it? Let's try question number 76. A student measures the terminal potential difference V of a cell as a function of I flowing through it. The slope and intercept of the graph between V and I then respectively are equal to, okay, 76 solution. So first of all, let me draw a combination of internal resistance, external resistance, EMF of the battery, and current flowing through it is, let's say, I plus minus, and here it is plus minus. Voltage across this internal resistance is IR plus minus. Just observe this, these two are looks like as a cells, they are connected in series opposing. Then the terminal voltage across resistor capital R is nothing but voltage across the cell, which is equal to let's name this is as V. So that's what they have given, no? Potential, a student measure terminal potential V. Yeah? Okay. So that is VT. I just represented it as VT. So VT is E minus IR as a source. They're asking graph. Okay. Now if you observe here, V is equal to minus IR plus E. So that is EMF is represented here. It is as E. So here just compare it with y is equal to mx plus c, where y is equal to v, c is e, r is m is minus r. So in this case, slope and intercept. Slope is minus r, intercept is e. For 76, option A is correct. Okay, let's move on to the next question. Number 77. For a cell, terminal potential difference is 2.2 volt when the circuit is open. Okay, super. When circuit is open, in the sense there is no current flowing through it, I is equal to 0. So if I is equal to 0, they give terminal potential as 2.2 volt. Is there any current flows through internal resistance? 0. Then voltage drop across internal resistance is 0. So you just can eliminate this. If we can eliminate this, EMF of the cell is nothing but terminal voltage here, which is replaced as E is equal to 2.2 volts. So that's the advantage of open circuit. You can find out EMF of the cell. Okay. Reduces to 1.8 volt when it is connected to a resistance of 5 ohms. Determine the internal resistance. Okay, super. So we're talking about terminal voltage, right? So let's place a resistor which is of resistance 5 ohm, and EMF of the cell is 2.2 volt, internal resistance let's say R. Now terminal voltage is reduces to 1.8 volt. Then how much voltage will drop across internal resistance? It's going to be 0.4 volt will drop across the internal resistance. Okay, is it 0.4? Yes. 2.2 minus 0.4 will give you 1.8, right? So let's say plus minus, this is how current enters. Let's find out the value of current. I is equal to V by R, which is 1.8 divided by 5. Let's just don't change this, just keep it as it is. We know the value of voltage across internal resistance, and equated to that, voltage across internal resistance is equal to I into R. VR value 0.4, I value 1.8 divided by 5 into smaller. So from this, small r is equal to 18 divided by 20, which can be replaced as 9 by 10 ohms is the correct answer. Option B is the correct answer for question number 77. Is it option B? Sorry, it's going to get reverses here, no? And R is equal to 20 by 18 will come, which will be equal to 10 by 9 ohms. Option A is correct, not option B. So let's try the next question, question number 78. A car battery of EMF 12 volts and internal resistance of 5 into 10 power minus 2 ohms. 12 volts, 5 into 10 power minus 2 ohm, which draws a current of 60 ampere from the external source. then the terminal potential difference. Okay, so here it is drawing a current from external source. So observe that the external source in the sense, is it current entering or leaving from the EMF of the cell? It is entering. This is how it is. So it's going to be plus minus, it's a 60 amperes, right? So here entering plus minus 60 into 5 is going to be 300 into 10 power minus 2 is going to be 3 volt. Now if you observe here, these two cells looks like as if they are connected in series aiding. So net voltage, terminal voltage is equal to 15 volt. We just have to add them because current is coming from external source. So current is not given by the battery, current drawn from the battery. That's the difference here. So which option is correct? Option C is the correct answer. So let's try 9th question. The internal resistance of the cell of EMF 2 volts is 0.1 ohm is connected to a resistance of 3.9 ohm. The voltage across the cell, they're asking nothing but terminal voltage. Okay. So this 2 volt internal resistance is 0.1 ohm. External resistance is 3.9 ohm. They're asking terminal voltage. Vt we have to find out. So we can use voltage division method. Vt is equal to, so 2 volt into same resistance or opposite resistance. While we are finding voltage division, same resistance we have to select, that is 3.9 divided by 3.9 plus 3.9 plus 0.1, which is equal to 4. So Vt is equal to 3.9 divided by 2. So we can write on Vt is equal to 1.95 volt as an answer. Which option? Option A is the correct answer for question number 17. This is one way. There is another way to find out. Yes, this I is equal to, you can find out current here. That is V by R. V by, what's the value of R equivalent here? It's going to be 4, right? Answer is going to be 0.5 ampere. And that current is flowing through the circuit in clockwise direction like this. So it's plus minus. Now these two cells looks like as if they are connected in series opposing. So current is 0.5. 0.5 into 0.1 is going to be 0.05, right? So as these two are connected in series opposing, E net is equal to, or V terminal voltage is equal to 2 minus 0.05, which will give you answer as 1.95 volt. Again same method. You can use both the methods. I think voltage division in rule is the best method to answer it is quickly. Okay, so let's move on to the next question. Question number 80. A battery of EMF 10 volts and internal resistance 0.5 ohm is connected across a variable resistor capital. Okay. EMF is 10 volts, internal resistance is 0.5 ohm, connected across a variable resistor capital R. It's variable. The value of capital R for which the power delivered in it is maximum. Value of capital R. So for maximum power delivered, it's a direct condition. For maximum power delivery, internal resistance must be equal to external resistance, which is equal to 0.5. It's a condition, basic condition. 0.5 ohms is the correct answer. So to get maximum power in the circuit, internal resistance of this circuit must be equal to external resistance. This is the point that you have to remember for maximum power condition. Hope you understand this topic, today's problem solving. Hope you enjoyed it, and go through this session again and again and again so that you will get 100% clarity on this. Thank you guys. Thank you for spending your time. Have a nice day. Thank you. Bye.